Back. So here we are at sorted set 1.py. We have started building our class. Now, what is this method index after? Let me run this. Okay, so now suppose you build a list. Let's call it just say 3, 4, 1, 2, 5, 3, 2. Suppose we built this list, right? Index of 3 is 0, this 3. So this is index 0. So A0 is 3. A1 is 4 and so on. 0, 1, 2, so on. Now, suppose you want a sorted set. All right. So suppose I say let B equal to sorted set of some list. Say I give it B. I'm using variables so we don't get confused with index and other things. So B, A, C, F, E. Say let me repeat a B. Closed it. Let's look at what is B. B is A, B, C, E, F. You see, it sorted itself. Now, suppose I want to insert somebody here, right? So I have B that is sorted. Suppose I want to insert a D, dog, right? So, in other words, I want to use the insert method, B dot insert the letter D. Okay, so D should now be able to go to the correct location. What is the correct location for D? D's correct location is where E was. In other words, you want to know the index after your D. That's what this method is for. All right. So, suppose A, B, C, D, E, F, G. I want to find G. I want to insert G. So, let me say B dot insert G. Correct? So, it's not giving me anything because G does not exist. You understand? Otherwise, let me say B dot insert G. It should return something. It is returning the none object. All right. So, it's not an insert. I'm sorry. B dot G has been inserted, but I wanted to find, so insert index after, say suppose I want to insert AA. Where would AA be inserted? AA is between A and B, so it should go there. That is the index. That's what you want to detect. So, how do you figure out the index after? Assume your index is after a 0. As long as the current index is less than the length of the list and your value is greater than or equal to the value at that particular index, keep updating your index. All right, that's all. You start with 0, look at your value. Is it greater equals this? Yes. So update your value to here. Correct? Your index to here. Then check. Is your new index less than the length? Yes, it is. Now, look at the value. Is it bigger than this? No. That's when you get out of the while loop and return whatever the index you had stopped at. That was 1. All right. That's what index after is good for. It is to figure out where you are going to insert any new value. Okay. Now, suppose you have found index after, now you are ready to insert. As long as value is not in your object. So, you want to insert only those things which are not in your object. Suppose I say b dot insert a. Look at a, it appears only once. Okay, it did not insert it. Whereas b dot insert aa, aa got inserted. You see, so you don't want to be inserting something that's already there. So as long as the value is not in your object, find the index after your value, consider that place, and use the insert method of the list class in that place of your given value. That's all. So notice, what are we using? We are using the parents method of insertion. All right. So this is our new insert method. So this is overriding an old insert method by using the old insert method. Okay. Append, define append. Normally in a list, any list, right? You append, that is, A was just a list. If I append something, that thing goes at the end. But that may break up our sort. So if I have B, I want to append, say, AB. I don't want AB at the end of B. Where was B? B is this. Okay. I don't want AB to go there. AB should come here actually after AA, before B. So notice, yes, AB. So you don't want to be appending whatever to the end. You want it to be inserted correctly, and that's all. All you do is invoke your object's insert and insert it in the correct location. Extend. What is extend method? Extend method for a list is simply not concatenating, but basically extending. For example, capital A is an actual list. So A dot extend with something else, 5, 1, 2. It will take, where is my latest A? That is my latest A. And that latest A has been extended by the other list I fed it. But that part will not keep it sorted. So in our sorted case, if I want to extend, I want to make sure whatever I throw in is sorted again. For example, what did I say? Suppose I want to extend it by Z, X, and say I throw in another AA. So mind you, I should be able to get rid of that AA and extend my B in order. So let's look at B now. So AA, there is only one AA, and X and Z are added in order. All right. So how do I extend? Well, use a for loop of the other list, iterate through the other list, and insert each element. Insert as in our insert that we defined. Okay. Likewise, adding one list to another. How do we add a list to another list? Okay. 5, 6, 7, it's simply extending it. All right. Now suppose I add a list, another list. Okay. So E, A, P, R, Q. All right. So E is here, A is here, so notice didn't get repeated. P was in place, Q was before R, even though we added later. It corrected itself. So that's what you want. So adding, you want to call the result to be first sorted set of self and use the extend method you have with the other. All right. Lastly, sort. Remember, list has a sort method already. List has a sort method already, but I don't want to use it anymore in my sorted set. So I say pass. In other words, I nullify the list sort method in our sorted set 1 method, right? Likewise, reverse. List has a reverse method inbuilt. It reverses it. But reversing a sorted set will give you a decreasing set. It's not the kind you want. So when you employ reverse method, you should raise a runtime error which says sorted set cannot be reversed. So suppose I have my B. B was my sorted set. Where was B? The final B is here, and I ask it to reverse, and it's raising a runtime error, exactly what I asked it to. Okay. Set item. Set item. Look, A is now this. So suppose I want to replace this 5 by 25. In other words, A, that is second index quantity, to be 25. This is what is set item. All right. So instead of using this approach, suppose I want to replace the 4 by 44, I can say A dot double underscore set item double underscore with 0, 1, 2, 3, 3 position. I want to replace it by 44. What does A look like? There. So set item method is nothing but what we have been using index directly. All right. Now I shouldn't be able to do any of that with a sorted set. For example, B, suppose B is, where was my latest B? Latest B is this. Suppose I want to write a CA there. So B1 equals CA. See, a user should not be able to do this, because if they did, you will lose the sorted nature of your list. And that's what it should run. It should raise a runtime error. That's what this method does. Okay. So that is our sorted set class, child of list class. Sorted set 1 is the completed version. All right. Until next lecture.